Hello everybody. Today I will present the paper Learning a Low-Rank Shared Dictionary for Object Classification. This paper is published in ICAP 2016. In this presentation, I will give you some overview about the problem, and then I will present the idea of the method called FTDL, and then the proposed method is just an extension of FTDL. And finally, I will present the result of the experiment. This is the problem description of the method. We have two phases. The first one is the training phase. For example, we have the data Y, which includes C classes, and our job is to find the dictionary T and the coefficient X, such that Y can be represented by T and X. After the training phase, we will have the trained X and Y, X and D, and then in the test phase, if we have a new example Y, and we will base on the trained T and X to determine which class the new example belongs to. And the motivation to this work is the most existing dictionary methods carry only the distinct class-specific feature, but in fact, objects also share the common patterns. So, based on this observation, the author use a share based on the well-known class-specific dictionary. The author used a shared dictionary with low-rank constraint to improve the accuracy. Now I will present the idea of FTDL, and then I will present the proposed method as an extension of FTDL. This is the idea of FTDL. We have the data Y, the dictionary T, and the coefficient X. And the characteristic of the FTDL coefficient is, the first one is block diagonal. It said that the coefficient is lie on the block diagonal. It is because each object is expected to lie in its own class of space, and all the class of subspaces are non-overlapping. And the second one is sparity. Sparity because only some element in X is activated, and the rest are zeros. So to obtain this characteristic, the cost function of FTDL is formulated by this formula, and later on I will present the intuition of this cost function. This is the intuition of this cost function. We have data Y, the dictionary D, and the coefficient X. So at the beginning, we assume that X is 0. I will divide the cost function into 6 main terms. The last one, is somewhat similar to the number 4. So I will present the number 4 instead of this one. The first term will activate the whole X based on Y and T. And we can see that on the first term, it is to minimize the distance between Y and Tx. So intuitively, we can see x will be activated. The second term will activate the coefficient that on the block diagonal. We iterate to the class and x subscript I and superscript I will be lie on the block diagonal. So this term will activate the coefficient on block diagonal like this. We have three blocks on the diagonal will be activated. The number 3 is to turn off the coefficient that are not on block diagonal. We iterate I and j, so this y is not equal j is not equal y, I is that is the block is not lie in the block diagonal. So this term will turn off the coefficient that are not on block diagonal. So the block that not lie on the block diagonal will be turned off. So next one will be encourage the disparity of the coefficients because we minimize the norm of x. So it will be some element in x will go to 0. So it means we increase the disparity of coefficients like this one. And the two last one is to increase the intra-class distance more and inter-class distance large. For example, we have 3 classes and we increase the distance between each point to the mean point of that class will be small, and the distance between each class will be large. So after define the code function, the learning rule is to fix x and update t and fix t and update x until the algorithm converge. After the algorithm converge, we will obtain d and x. So if we have a new example y, firstly we will find the coefficient vector that satisfy this formula, and then based on x hat, we will do classification by this formula. We will find c based on the distance between our vector and the dictionary, and this is to make sure that our solution is correct. This is the confident to make we are more confident about our result. For example, we have a new example y, and we have the coefficient x. So based on this formula, we find one coefficient vector. For example, it is this one, and then based on this one, we will know that it is like on class red, class number 2. So y will be turned on the number 2. We will determine that y will be on the class number 2. And this term is a distance between the x and the mean point. So if this distance is small, we are more confident that our decision is correct. Now I will introduce the proposed method. So in proposed method, we will use 2 dictionaries. The first one is a class specific dictionary, it is green, red, and blue, and the shared dictionary, it is in brown. And also we will have the coefficient for shared dictionary. So now the dictionary will become D bar. This is a concatenate of T and D0. D is a class specific, and D0 is a share pattern. It is similarly we have X will be concatenate of X and X0. Now the code function will be defined as J D bar and X bar minus this term, where the first term is the code function of FTDL with new variable T bar and X bar, and the second term will be increase the low rank D0. So the question is why we need a no rank of the shared dictionary. Intuitively, for example, we have two class 1 and class 2. In an ideal case, we have this region is the ideal shared subspace. But if we don't have the no rank constraint, just shared dictionary, we also observe the discriminate atom. This is a discriminate atom. So we don't want that happen. So we make the constraint of low rank to make our region smaller. So after define the code function, the learning and testing procedures is somewhat similar to FTDL. Now I will present the experimental result. This paper will do the experiment in three data sets. The first one is Caltech 101. The second one is extended GeoB, and the last one is ARFACE. Our method is the last one, is the last row, and it is compared to the other methods. This is our method. As we can see that by using the shared dictionary, our method improve the accuracy of 3 datasets, and it outperforms the other method in accuracy of object classification. In conclusion, by using the shared dictionary with low rank constraint, the proposed method outperforms the state-of-the-art shared dictionary learning method. This is the end of my presentation. Thank you for your attention.